Hello everyone, I am Maheshwari, Assistant Professor, Department of BSc Information Technology at Dr. S.N.S. Rajalakshmi College of Arts and Science. Now I am going to explain about CPU scheduling. The CPU scheduling is a very important task in order to complete a particular task within a time with the help of operating system. The scheduling is the process of processes or work that is done to finish the work on a time. The CPU scheduling is a process that allows one process to use the CPU while the another process is delayed due to unavailability of any resources such as input, output, etc., thus making full use of the CPU. The purpose of CPU scheduling is to make the system more efficient, faster and fairer. Whenever the CPU becomes idle, the operating system must select one of the processes in line ready for the launch. The selection process is done by a temporary CPU scheduler. The CPU scheduler will help to choose the next job to the processor. In this diagram, we have a number of devices which helps to complete the task with the help of an operating system. The first one is pull-off job in the disk. This is a long-term scheduler. This helps to access the available resources and executed processes inside the ready queue. The ready queue contains a number of process which needs to be executed. In this ready queue, the CPU will fetch the process and execute it and send the output to the users. This is with the help of short-term scheduler called dispatcher. The dispatcher will helps to take the process from the ready queue and assign it to the resources. The dispatcher will send the midterm scheduler, that is nothing but the waiting queue. The waiting queue contains a list of process. Each process can use a different input output resources within a time. The CPU scheduling has two types. The first one is preemptive scheduling and non-preemptive scheduling. In preemptive scheduling, we cannot forcefully take out the process from the resource. During a non-preemptive scheduling, if we want to do a higher priority process, so we can take the process from the resources forcefully. That is called a non-preemptive scheduling. In preemptive scheduling, the tasks are mostly assigned with their priorities. Sometimes it is important to run a task with higher priority before another lower priority task. Even if the lower priority task is still running, the lower priority task holds for some time and resumes when the higher priority task finishes its execution. In non-preemptive scheduling, in this type of scheduling, the CPU has been allocated to a specific process. The process that keeps the CPU busy will release the CPU either by switching context or terminating. It is the only method that can be used for various hardware platforms. That is because it does not need a special hardware. For example, it is a timer like preemptive scheduling. This scheduling will help to allocate the resources within for the process. It may be either preemptive type or non-preemptive type. The important terminologies which can be used inside CPU scheduling. The first one is burst time or execution time. This is known as the time taken by the process to complete the execution. It is also called as running time. This simply in simple manner we call the execution time of a process is known as burst time or execution time. Arrival time, when a process enters in a ready state. From this ready state only we can take the particular process and assign a resource to that process, then we can execute and sends the output to the user or interfaces. Multi-programming, a number of programs which can be present in the memory at the same time. Since the memory has a number of programming which also can executed at the duration of a time. Jobs, it is the type of program without any kind of user interactions. User, it is a kind of program having user interaction. The users are nothing but the particular end user. With that we are going to supply input and receiving an output. Process, it is a reference. It is the reference that is used for both job and the users. CPU or input-output burst cycle characterizes process execution which alternates between CPU and input-output activity. The CPU times are usually shorter than the time of input-output interactions. Thank you.